page 31, light review. Look at your science notebook. Maybe at the top of page 31. Light. Bell ringer. As usual, part A is just a vocabulary review. So let's talk about what is light. I kicked this question back to a lot of you on Progress Book. This question got kicked back to a lot of you. Some of you told me it was a hot ball of plasma. That would be the sun. We want to talk about what light is. Some of you said that it was hot. It can be, not, it's not always immediately warm. Heat is an aspect of light, or can be an aspect of light. We're trying to look at what is light as a physical science sense. What is it in terms of physical science?
Things visible, but some light cannot be seen.
Okay, so it can add a visual aspect. That's true. There's a visible light spectrum. And a lot of you said that. And I probably kicked it back to you and said, is it just this? So nice addition there, Mr. Jones. It's not all visible light. So it is energy. It is electromagnetic energy. Okay?
I was going to say that.
So it's like
steal your thunder
it's
there.
like heat waves, like light waves, heat waves.
It is electromagnetic energy. And then to take this a step further, we're going to say that light specifically, because we know that light travels on EM waves, okay, that it is electromagnetic energy that is carried by EM waves. Those electromagnetic waves, those oscillations of electric and magnetic fields. Evan, put the calculator down. Okay. Yes.
Doesn't like heat make light? Because like, in the deserts, it's like really hot during the day, but then it gets really cold at night. And like, even like during the day when it's light out, it's hotter.
So light, heat is an aspect of light. Heat is not created by light. So that's kind of what's important here is those EM waves, those oscillations, okay? When you have the electric field oscillating alongside the magnetic field, when you have both of those things oscillating together, vibrating together, creating that EM wave. Yeah, right over there, Claire. Dog is having a sneezing fit. Anyway, when you have these EM waves and you have those two fields oscillating together, you create or you have this transference of electromagnetic energy. That's what light is. And heat is an aspect of that. It does not create that. Does that make sense, Mr. Jones?
Yes.
Okay. What then, so if light is carried by these electromagnetic waves, what then is an electromagnetic wave?
Whoops.
All my pens are done. Hold on. Giant pencil it is. Electromagnetic wave. Okay. What is an electromagnetic wave? What is an electromagnetic wave? I just said it in the last explanation. Grace?
A light wave?
Yes and no. Light is electromagnetic energy carried by these waves. So what is this wave?
Oscillation.
Oscillation.
Oscillations of Deegan.
Ah, crap. No.
Oscillations of, they're
Light
called
waves?
electromagnetic waves for a reason. Gabe, do you know?
Why are you asking me? Why do you think I would know?
Because you are so good at paying attention.
That's a lie.
Gabe, because Mr. knows you need to try harder.
No, he tries plenty hard, Zeppelin. Thanks for your input. Gabe, you have a guess?
To guess.
No.
All right. Gavin?
Oscillations of electromagnetic.
Yeah, of electric
energy?
and magnetic fields. So, guys, remember, we don't name things in science willy-nilly. We call them what they are. It is a wave in the magnetic field and a wave in the electric field. We call them exactly what they are. Electromagnetic wave is a wave in the electric field and a wave in the magnetic field, and they're traveling together. They're creating this pseudo-resultant wave. Okay? And at this point right here, to understand this concept, this word, this electromagnetic part, again, I'm going to encourage you, watch that Kurskazat video that's on the 5th grade website. It's going to really help you. He's got some really good pictures that go along with this idea to explain that. So if you haven't seen it yet, go see it, okay? I'm going to put, just like I did in the last video, I'll put a link like right here, right now, actually. It'll be right there if you're on the YouTube channel, okay? Now, visible light. What is visible light? Mr. Jones clarified for us that light includes visible light, but is not just visible light. So what is visible light?
Oh, no.
Zayden, what's visible light?
Mom, what's visible light? Huh?
I didn't say ask your mom, Zayden. What's visible light? In science, we call things exactly what they are. Who thinks they know what visible light is? Skylar?
Is it light you can see?
Yeah. Yeah.
Very self-explanatory.
It's light we can see. Okay? This includes colors. It is not strictly limited by colors, but it is mostly colors. Any color that you see is a light wave that you can visualize. Red, blue, any combination therein. Okay? All the Roy G. Bivs of the world. Black being no color, white being all color. Visible light is light you can see.
Wait, so white is a rainbow?
White is all of them combined, which is why when you take white light and you refract it, say through a raindrop, you get a rainbow.
Cool.
Yeah, so that's where rainbows come from. It's that refraction. Remember we talked about refraction being the slightly bent light wave? So it bends along the, it's a light wave that bends in accordance with its wavelength. So something that's 900 nanometers versus 700 nanometers are going to bend at a slightly different angle. That's what creates the spectrum of visible light, which is Roy Viv.
That's pretty cool.
Yeah. And then we have this idea of luminosity. Now, luminosity, again, is the scientific term that we're using so that we can calculate something that is affected by the amplitude of a wave. Okay, so it's calculable. The reason we don't call it this other word is because that's more objective. It's more subjective. Okay, luminosity is what from last week? What did we call luminosity? What did we say that luminosity was? Starts with a B. Jillian?
Brightness.
Yeah. It is the brightness or intensity of visible light. And Oakley last week said, hey, I have a really good word. Instead of saying, the brightness, he said, we can call things extremely luminous. And that's correct, because if you have something that's super bright or super intense, like, whoa, that light's really intense, we could also say that it's very luminous. And luminosity is this measurable aspect of the wave. Okay? Now for part B. So according to the graph, how does the amplitude of the light wave change? Okay. So we have our amplitude measure here. We have our positives. We have our origin. Up here is a positive. Okay. So what is happening from this point to this point? I started here. I went here. What's happening?
The positivity increases.
Okay. So as amplitude is increasing, and don't worry, we're going to write this statement in our science notebook as well. So we're starting here as that amplitude is increasing. Well, we also have our luminosity. So starting here, ending there, same points on the graph. Start here, I end there. What's happening to that luminosity?
The luminosity is increasing.
Yep. And remember, as we're analyzing graphs, we're really just looking for, are the numbers going up or down? And are they happening in relation to each other? So in this graph, they have a relationship, because as this is going up, this is also going up. Do you guys see that? Okay. So our statement rewritten in part B, whoops. As the amplitude, okay, of a wave increases, hold on, somebody's trying to join. As the amplitude of the wave increases, then the luminosity of the wave increases. Remember what we wrote last week, that there's a relationship between these two aspects, between a wave's amplitude and the wave's luminosity. Okay, I'm just scooching it just a little bit. Not getting rid of it entirely. Part C. Do you think it is important to understand the difference between light as a whole and visible light?
Yep.
Okay, Mr. Jones, why?
Because some people think that there are two kinds of light. Oh, there's one kind of light, but there's really not. Light can be in all forms, really.
Okay, so some people need to know that there is more than just visible light. Did I sum that up right for you?
Yeah.
Okay, does anybody say no? Does anybody think no, it's not very important? That's fair. Does anybody have another yes explanation? Another reason? Okay. I would say that another yes reason is the example of infrared. Okay. We can also feel light. Infrared is a light that we can only feel. Okay. UV light cannot be seen,
Hysteric.
but can cause sunburn. Yes, Oakley?
I can't really think of like an example of non-visible light.
Okay.
Can you like give me an example of non-visible light?
Infrared is non-visible. It's an invisible light, but you can feel it when you go outside later today. Hopefully, you're gonna feel your skin warm up when you stand in the sunlight, or even this summer, you're gonna feel that it's nice and warm out.
Oh.
And that's that infrared. So you're getting all that white light, you're getting all that visible light, but at this end, because again, light's a spectrum. So I'm gonna scooch this down a little bit more. I'm gonna draw you a picture. If light is a spectrum, okay? Only this tiny bit is visible light. So you've got your red, orange, yellow, green, blue, indigo, violet. Okay, from here to here. Well, right there is UV light. Okay, that's what can cause skin cancer and sunburns. But it also does things like help us process vitamin D, keeps my shell nice and hard. It's a necessary part of life. So there you've got UV. And
Without
right
it,
there,
you would be doomed.
right there, you have infrared. You can even see the word red in there, infrared. And that's the heat. That's that light that you can feel. So those would be two examples of non-visible light for you there, Oak. And then, of course, I've talked about radio waves and X-rays and all of those other types of waves that are on this spectrum. They're somewhere in here, but we can't see them. Okay? Now that's it for the day. Does anybody have any questions?